this lesson, we'll be discussing correlation coefficients. By the end of the lesson, you should be able to analyze a scatter plot and identify if the data has positive, negative, or no correlation, and assign a coefficient that describes the strength of the correlation. So a correlation coefficient describes the strength, whether it's weak or strong, that relationship. We're also going to call it R and assign a number, so it's going to be a decimal between +1 and -1 that describes that relationship. So over here in this picture, the green line is a +1 slope. It also has a correlation coefficient of 1 because all of the dots are exactly on the line. Same thing with the red one, except it's a -1 slope, and our correlation is going to be -1. Again, all the dots are on the line. As opposed to this example down here, when we draw the line, you can see that the dots are very close, but they're not exactly on the line. So our R would be -0.9. This one, we have this pattern that shows it's going negative, but the points aren't very close. So we're going to call that R equals -0.2. In this third example, we couldn't even make a line going positive or negative. In the fourth one, we can see that it's a pattern and it's going positive, but the points aren't very close to the line. So we're going to give that an R of 0.2. In this one, the points are pretty close to the best fit line, so we'll give it a 0.9. So when we're estimating the correlation coefficient, remember it's very subjective. So you first have to decide, is it positive, negative, or none, and then decide how close the points are to that line. If they're very close, it's a strong relationship. If they're not very close, it's a weak relationship. So here, again, this one has a negative strong correlation, -0.9. This one has a weak negative correlation, -0.5. Third example, no correlation. The fourth example, there's a positive correlation, but the dots are not very close, so we'll call it weak, and it's 0.5. And this last one is strong. All the points are fairly close to our best fit line, so 0.9. When we're describing the relationship, if it's a positive relationship, we say as whatever variable is on the x increases, the variable on the y increases. If it's a negative, we say as the x increases, the y decreases. So for example, the data below shows the relationship between the height and weight. Make a scatter plot and answer the questions. So we have a table with our x values and our y values. So we'll go ahead and plot these. So 60 and 100 is here. And then we plot the rest of them. And if we draw a best fit line, you can see that it's definitely positive. And it has a strong correlation, but it's not perfect. So we might give that a 0.8. When we describe it, we would say as the height increases, the weight increases. Second one says estimate the correlation coefficient closest to -0.9, -0.5, 0, 5, and 9. So it's giving you just those 5 choices to describe it. So in this first one, we draw our line. We can see that the points are fairly close, so we would call it 0.9. And the description as experience increases, income increases. In the second one, we draw our line. It is positive association, but it's not very strong, so we're going to give it 0.5. Our description as quality increases, the price increases. In this one, we can see that there's a negative correlation, but it's not very strong, so we'll call it -0.5. Our description as classes missed increases, the exam score decreases. And this last one, again, we have a negative. The points are a lot closer to our best fit line, so our description would be as time increases, the rain decreases. And we'll give it a correlation of -0.9. So just a few more estimating. That one is definitely negative, and I'd probably give it a -0.8. This one is positive. Again, the points are going to be pretty close together. So positive 0.8, maybe 0.7. And this one is definitely no correlation, so 0. And this one, oh, it's definitely positive. And see how close they are? So I might give that a 0.9. Here we have a negative correlation, but they're not super close. I might give it a negative 0.5. And lastly, we have a positive correlation. They're pretty close. I might give it a 0.8. So when we're estimating the correlation, this one negative and pretty close, so negative 0.9. This one no correlation, so 0. And this one is positive, but it's not very strong, so I might give it a 0.7, 0.8.